Can you see it now?
Yes.
Good. So what's the answer? Which one is alkyne?
A.
Correct. Oh, sorry. I was the one that did that. Don't mind me. Don't mind me. Okay, so let's continue. Now, moving on. The next guys we are going to talk about are alcohol. Now, alkanols, let me even say something about alkanols. It's important I say this thing. This thing even came out today. Now, alkanols are characterized by the hydroxyl group. What did I say? Alkanols are characterized by what? Hydroxyl group. What did I say? Alkanols are characterized by hydroxyl group.
Hydro.
Thank you. So whenever you see hydroxyl group, it is alkanol. Now, if there is one hydroxyl group, you call it monohydric alkanol. One hydroxyl group, monohydric alkanol. If there are two hydroxyl group, dihydric, and so on and so forth. But I don't want to spend my time on these other ones. The one I want to talk about is monohydric alkanol. Now, monohydric alkanol has three classes. The first class is primary. Second one is secondary. And third one is tertiary. Did you get this thing I just said? Did you get this thing?
Yes.
Now good. Now let's understand it. For you to understand the classes of alkanol, the first thing you need to know is the classes of carbon. So let's get classes of carbon first. So if you look at the carbon atom, a structure like this, let's give them numbers. 1, 2, 3, 4, 5, 6, 7, 8. You don't need to write it. It's something that it can enter your head straight up. Listen. The first class of carbon atom is primary carbon. Now, when you say that a carbon atom is a primary carbon atom, what does it actually mean? It means that that carbon atom is terminal. It is at the extreme. It is the last carbon atom in the chain. Mona, did you hear what I said?
Yes.
Did you understand what I just said?
Yes.
Good. So with that said, which one of them is supposed to be a primary carbon now?
5.
5, correct. Is that the only primary carbon atom there? So primary. This one is the last
1.
now. 1, good. This one does not have any other carbon above it, so primary. What about this one? Yes, now is there any carbon after
Yeah.
it? No, so it's primary. Is there any carbon after this one? So it's primary. I hope you understand the concept of primary carbon atoms now. Once it is the last carbon in the extreme or the extreme carbon, it is primary. Now, if I put hydrogen here, is it still primary?
Yes.
It's still primary because it's still the last carbon, even though there is hydrogen. I hope you are getting the points now. Good. So now another thing about primary carbon atom is that it is directly attached to only one carbon atom, not one atom, but one carbon atom. So this guy is only attached to one carbon. This guy is only attached to one. This guy is only attached to one. Now, secondary. Secondary is attached to two carbon atoms. Oh yeah, which of them is attached to two carbon atoms? Tell me. Yes?
4.
Huh? 4.
4.
Correct. So 4 is secondary. I hope you got this thing now. So 4 is secondary.
Yeah.
Good. So C4 is secondary. Here, primary is C1, C5, C6, C7, and C8. Okay, then we go to the next one, tertiary. How many will tertiary be attached to? 3 carbon, not just 3 atoms, but 3 carbon atoms. So which one is tertiary? Which one is tertiary?
2.
2, correct, good. So 2 is tertiary, correct. So C2 is tertiary. Then finally, you have quaternary. Quaternary. Quaternary is attached to 4 different carbon atoms. Which one is quaternary?
3.
Exactly. And this is quaternary. Good. So C3. I think you can you do you want to put this? Just put this down. Primary carbon directly attached to only one. Secondary two carbon atoms. Tertiary three carbon atoms. Quaternary quaternary is four carbon atoms. Then you just put the examples and draw this structure and label it. If you are done, you tell me so that we'll talk about alkanols quickly.
I'm done.
Oh, good. Now, how do you now know a primary alkanol? You know, if OH is attached to a chain of carbon, the OH will make that whole compound to become an alkanol. So if I put the OH on a primary carbon, this OH will make this primary carbon to become and turn the whole compound to a primary alkanol. Did I confuse you?
No.
Okay, so which means if I put OH here, what type of alkanol will it become?
Tertiary carbon.
A tertiary alkanol, because OH will make the whole compound to be an alkanol. Are you get what I'm saying?
Yeah.
Good. What if I put the OH here? What type of alkanol will this become?
Secondary
Exactly.
alcohol.
So you can put that down if you want. That primary alkanol has OH on a primary carbon. Secondary alkanol has OH on a secondary carbon. Tertiary alkanol has OH on a tertiary carbon. Just put it down like that, simple, and we've understood that. Okay? Are you done?
Yes.
Okay. With that said, we have understood how to identify it based on the position of OH. The other thing we need to understand is how to identify a primary, secondary, and tertiary alkanol based on their name. Did you hear what I just said? Because sometimes they will not give you a structure. If I draw a structure like this now, look at this structure. If I draw a structure like this, okay. Now, whenever you see a compressed or condensed structure, the first thing you need to do is to expand it. How do you expand it? It's very simple. Look, after each carbon, anything in front of the carbon surrounds the carbon. So if you write carbon, what is in front of it? H. How many H? 3H. So surround it. 1, 2, 3. Then you go forward to the next carbon. This carbon, right? What is in front of this carbon? OH is there. And then CH3 is also in front of it. So you put the CH3 down. Then you continue. Now, once you come to CH2, please, the number of times they write the CH2, just write it as part of the chain. So you write CH2 1, CH2 2, CH2 3. Not CH3, CH2. Sorry, did you get what I just did? Hello?
Yes.
Good. Then you continue. Next carbon is here. What is in front of it? 1, 2, 3. Now let me ask you, what type of alkanol is this guy? Primary.
Tertiary.
Exactly. Correct. So you can put that down. This is a tertiary alkanol. Now, this is basically how to differentiate between them. That is when you're looking at their structures. So the next thing we're going to do is how to differentiate between them when you're looking at their name. So when you consider the name of an alkanol, how do you differentiate between alkanols on the basis of their name? Are you done? Okay, good. Now, with that said, yeah, so now how do you differentiate? Now, if it is a primary alkanol, how you will know a primary alkanol based on the name is that there is no locant or number before all to indicate, like before OL, to indicate hydroxyl position. So once you notice that I write this, option A, propanol, option B, propan2ol, If there is no number before the or, suspect it to be primary. Do you get what I'm saying?
No.
Okay. Let's take this again. But write this down, Sha. If there is no locant or number before all, okay, or all to indicate OH position, or no number before the alkanol's name indicating the position of OH. Just put this down, then I'll explain. Are you done?
Yes.
Okay, so look at this. If I write propanol and write propan 2-ol and write 3-methyl propanol and write 3-methyl sorry, it can't be 3-methyl, 2-methyl propanol and write 2-methyl propan 2-ol. Look at this thing now. A, B, C, D. Sure, you see this one now. Are you seeing any number before all?
Yes.
Is there any number before all?
No.
What about here? Is there a number before all?
No.
In the B?
Yes.
Is there a number before all in this one?
Yes.
In C?
No.
Is there a number before all in D?
Yes.
Good. So because you are looking at a primary alkanol, there will be no number before all. So is this primary, secondary, or tertiary?
Primary.
No number before you write the all, so it's primary. Do you understand? That's how to know from their name.
Yes.
What about this one? Can this one be primary?
Yes. No.
This is not primary. We'll get to what this is. What about this one? 2-methyl propanol. Is there any number before all?
No.
So this is also primary.
Primary.
Are you following? Then here, 2-methyl propan. Is there any number before
Yes.
all? Yes. So this is not primary.
Yes.
So the only primary here are A and C. You can put that down. You can put that down. Why I'm explaining this is one of the questions they asked today has to do with this thing I'm saying. And I'll tell you why I'm explaining this.
I'm down.
Okay, very good. Now let's go to secondary. Secondary alkanol. Secondary alkanol has a look at. Okay, before I go to secondary, there's another thing I'd like to say. Now, primary, if you can have propan 1-ol. If you see propan 1-ol, it's still primary. So it's either there is no number before all or that the number before all is 1. That's how to know primary. Did you get what I just said?
Yes.
Okay, good. So, but for secondary, it will have or it has a locant greater than 1. Greater than 1, which means 2, 3, 4, 5, see, anything greater than 1. Are you following me? It has a locant greater than 1 to indicate hydroxyl group position. So if I write hexan 2-ol, hexan 2-ol, is this secondary? What if I write hexan 3-ol? Is this secondary?
No.
Why is it not secondary? Is it not greater? Is 3 not greater than 1?
Greater than 1.
Yes, now that's the see. Once it is secondary alkanon, remember, you know what we did that time is primary, secondary, and tertiary carbon. That's a different ball game. I'm trying to tell you how you will use the name to know if it is primary, secondary. It's different now, so you need to like understand that this is a different paradigm. Do you get? So look at this thing now. A secondary alkanol has a locant greater than 1 to indicate hydroxyl group position. So in this case, 2 is greater than 1. Here, 3 is also greater than 1. So is this secondary? Yes, because it has a number greater than 1 before O. Okay, what if I write this thing now? If I write octane 4O, is this still secondary?
Yeah.
Yes, that's secondary. Now, how do you now know tertiary alkanol? So tertiary alkanols have locants. Okay, no. Okay, have the locants of OH before all and the locant of an alkyl group as the same number. As the same number. As the same number. As the same number. Okay, so look at what I mean. If you see that there's an alkyl group in the compound and the number of the alkyl group and that number before all is the same thing, it means that it is now tertiary. But if they are not the same thing, it is secondary. Look at what I mean. If I write something like this, 2-methyl propan 2-ol. Are you looking at this?
Yeah.
Notice something. The number before all is the same thing as the number of the alkyl. It could be methyl, ethyl, propyl, any ill. Once the number of the OH, which is before all, and the number of an alkyl group are the same thing, it is tertiary. Did you hear what I just said?
Yeah.
Let me give you another example. What about this one? 2-methyl pentan 3-ol. Is this tertiary?
Yes.
No. Think again. If it is tertiary, the number of the alkyl group, alkyl, will be the same thing as the number as the ol. Are they the same thing here?
No.
So is this tertiary? No. It is now what? Secondary. Should I give you another one?
Yes.
Oh yeah, look at this one. Imagine I write 2-chloropropan 2-ol. Is this secondary or tertiary?
Tertiary.
How is it tertiary? Why is it tertiary?
Because the number of the alkyl.
This is not alkyl. That's my problem. Is this alkyl? This is chloro. Do you understand?
Yes.
So this is not alkyl. So which means you're not considering this guy at all. Which means this is secondary. Are you seeing how they can twist the question and students begin to fail? Sorry, did you understand what I explained in this one now? Because this is not alkyl, you can't consider it. This is secondary. Look at this one now. If I write, sorry, if I write something like, yeah, 3-ethyl hexane 3-ol. Primary, secondary, or tertiary?
tertiary.
Good. Why is it tertiary? The alkyl number and the number before on are the same thing. Sorry, have you gotten this thing now?
Yes.
Okay, good. Now let's do some. We are done with identifying with. You know what we did now is we differentiated based on structure. We differentiated based on the name. Now let's look at reactional differences between primary, secondary, and tertiary alkyl. Write it down. Reactional differences between primary, secondary, and tertiary alkyl. 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 Are you done?
Yes.
I are good. So let's get to it. Now, if you want to differentiate between a primary, secondary, and tertiary, there are two ways, two major ways. The first way is using Lucas reagent. What do I say is the first way?
Using Lucas
So if they
reagent.
ask you what is Lucas reagent used to do, it is used to differentiate primary, secondary, and tertiary alkyl. So you can put that Lucas reagent, it is used to differentiate primary, secondary, and tertiary alkyl. So what is inside Lucas reagent is zinc chloride and hydrochloric acid. What did I say Lucas reagent is used to do? Differentiate primary, secondary, and tertiary alkyl. Take note of that. Okay, now that you've said that, are you done? Can I continue?
Yes.
So Lucas reagent, or yeah, Lucas reagent, let's use, plus a tertiary alkanol, turbidity will form immediately. When I say turbidity, it means that it will form a precipitate immediately and the solution will become unclear immediately. As you are pouring in the Lucas reagent into a tertiary alkanol, it will show turbidity immediately. But if you are dealing with a secondary alkanol, turbidity will show after 5 minutes. But if you are dealing with a primary alkanol, there will be no turbidity. Please take note of these things because this is a reactional difference between primary, secondary, and tertiary alkanol. Done? Done?
Yes.
Good. Okay. Having said this, the next one is using oxidation. Now, number two reactional difference is primary alkanols. If you oxidize them, the first thing they will give, do you know? Give me an example of an oxidizing agent that you know. Give me an example of an oxidizing agent that you know.
Huh?
An example of an oxidizing agent that you know.
Yes.
An example of an oxidizing agent that you
Oxidized.
know.
Um. Hi. Oh,
Haven't you heard of KMNO4 before?
yes.
Acidified KMNO4. Now, see the jam question that came out today based on this thing we studied. Listen, see the jam question. I just saw it now. Listen. They said, what alkanol reacts with Lucas reagent? What alkanol reacts with Lucas reagent? Based on what you have up there or in your note, which one does not react?
Primary
Good.
alkaline.
Then which one do you think is the one that will react fastest?
Tertiary
And that's the answer. Do you get what I'm saying? So once you are asked what alkanol reacts with Lucas reagent, that reaction that I have given you says that Lucas reagent reacts immediately to form turbidity with tertiary alkanol, reacts after 5 minutes with secondary, and there is no reaction with primary, which means primary no reaction, tertiary is the highest reaction. Now, if they put secondary there, know that your answer is still tertiary. I hope you are getting what I'm saying. Because tertiary is the one with the fastest and highest reaction. Okay. So that's that basically. Moving ahead. Moving ahead. As I get to those questions, I would I would just be highlighting them. Okay, so yeah, moving ahead. I was saying something. Primary alkanol. When you oxidize a primary alkanol, it is going to give you a secondary alkanol. Hey, what am I saying? Sorry. When you oxidize a primary alkanol, it is going to give you a corresponding alkanal. It is going to give you a corresponding alkanal.
Oh,
Yes. Primary null will give you null. And when you now further oxidize this alkanal, it will now give you alkanoic acid. Now, popular oxidizing agents that you could consider are things like acidified KMnO4 or K2Cr2O7. So once you see that they are using these guys, it means that they want you to do oxidation. You get what I'm saying? So once you see a reaction between K2Cr2O7 or KMnO4, the implication is that that reaction is an oxidation process. Now, with this said, is ethanol primary, secondary, or tertiary?
it's primary.
Why is it primary? There is no number before all. I've stated this. Once there's no number before all, or if the number is 1, it is primary. Now, when I oxidize it, it will give me ethanol. This question came out today. Are you listening to me? See the chemical formula of ethanol. C2H5OH. When you oxidize it, it is going to give you H3, C double bond OH. If you don't write it like this, you write it like this: CH3, CHO. Are you with me?
Yes.
Okay, good. Now, if you now further oxidize ethanol, what will it now give you?
Ethanoic acid.
Exactly, ethanoic acid. It's very simple. Ethanoic acid, which is CH3COOH. So which means this first oxidation that occurs is called partial. But when it now occurs completely, this is now called complete. Are you seeing what I'm doing? Hope you understood this.
Yes.
Okay, good. Propanol, what will propanol give on partial oxidation? Propanol, what will it give?
Ethanol.
Good. 2-methyl propanol, what will it give? Two methyl propanol, is it primary, secondary, or tertiary? Just think, it's very easy. 2-methyl propanol. You are asking yourself if there's any number before or for it to be primary, there's no number. Primary, good. So 2-methyl propanol will give 2-methyl propanal. Do you understand?
Yes.
And then 2-methyl propanal will now give 2-methyl propanoic acid. Is this in hard?
Yes.
Hope this is fully understood.
Yes.
Okay, good. Moving ahead. What's the next one? Secondary. Now, a secondary alkanol, when you oxidize it, it would only give one product, and that product is corresponding alkanol. Corresponding alkanol. What did I say that product is? Corresponding alkanol. That product is what? Known. Yes. So if I write propan 2-ol, is this secondary or tertiary? Eh?
Second.
Good. So what is it going to give me? Propan
Propanol.
2-ol. Yeah, you could just say propanol. Yeah.
2-ol.
2-ol. Yeah. Now, if you have 2-chloropentan 2-ol, What is this? Secondary or tertiary?
Second.
Still secondary because this 2 chloro, this is not an alkyl group, so you won't consider it. So it's still secondary. What will it give? It will give 2 chloro what? Pentan 2O. Did you get what I just said?
So,
Is it clear?
yeah.
Good. But when you are now
Yeah.
dealing with a tertiary alkanol, when you oxidize it, now look at what happened. Primary gave 2 products, secondary gave 1. How many will tertiary give? Primary gave 2, secondary gave 1. How many do you think tertiary will give?
Zero.
No reaction. Thank you. So that's that. So tertiary alkanols are not oxidized. Do you understand what I'm saying?
Yeah.
So that's that basically. So you can put this down. Put this down if you are done, you tell me. Fast, we don't have time.
I'm done.
You are done. Good.
I'm done.
Thank you. Now, having mentioned this, the next thing we are going to let's look at the other functional groups quickly, so that we'll highlight one or two other things. Now, if you want to know, we are done with alcohol, so go to ether. Ether is a compound that has the functional group as oxygen. If oxygen is found between alkyl groups, it is referred to as an ether. So if you have oxygen at the center, and there's an alkyl group here, and there's another alkyl group here, this is what? Ether. Are you following me? Now, one important thing I would like to say about this ether is the lab preparation. The lab preparation is very similar to that of ethene, and JAMB can decide to confuse students using this reaction. So see what I mean. If you combine alcohol with excess conc H2SO4, and you combine excess alcohol with conc H2SO4. Notice that in the first reaction, who is excess? Who is excess?
Okay, so.
Thank you. But in the second reaction, who is excess? Alcohol. It's still alcohol and H2SO4, but this excess has changed the reaction. If H2SO4 is excess, what you produce is alkene. It is a dehydration reaction, which means it will remove water. So basically what this means is, if I tell you ethanol plus excess H2SO4, my answer, alcohol gives alkene, so ethanol will give what? Ethene. Do you get what I'm saying? So, but that is when H2SO4 is excess. The temperature of this reaction is usually about 180 degrees. That range. You get what I'm saying? So just take note of that.
Yeah.
That if H2SO4 is excess, it will give alkene. Now come here. If you have excess alcohol and conc H2SO4, it will give ether. The other way of calling an ether is alkoxy alkane plus water. So it's important you highlight and take note of this. If H2SO4 is in excess, it will give alkene, but when the alcohol is in excess, it will give an ether. Okay, now, if I have this thing now, imagine I have excess propanol plus conc H2SO4. What it will give, listen, what it will give is, it's propanol. Are you following?
Yeah.
So what it will give is propoxypropane. That's prop will give propoxypropane. So what if I had excess butanol? Please, what is it going to give me plus conc H2SO4? What is it going to give me? With
Oxybutane.
oxybutane. Good. Good. Now, another way of calling propoxypropane, there are two props here now. There are two props.
Yeah.
So you just call it dipropyl ether, which means this oxybutane will now be what? Di what? Dibutyl what? Ether.
Yeah.
I know it's going to be like a little bit confusing, but as you're looking at it again and again, you are getting used to it and you're understanding the concept of this reaction. You get what I'm saying? So take note of this reaction I just said. Take note of it. It's one reaction that they will use to confuse most students in JAMB hall, because almost everybody knows that the hydration of alcohol gives alkene. But once they mention excess conc H2SO4, that dehydration will give alkene. But if it is excess alcohol, it will now give your ether instead. So take note of that. Take note of that. And it gives a symmetrical ether. Anyway, to form an unsymmetrical ether, you are going to be using Williamson's technique. But that's not your level. Let's leave it. Are you done writing?
Yeah.
Okay, good. So we have understood ethers. I think one of the most popular ethers is diethyl ether. Diethyl ether. And what is it mostly used for? Diethyl ether is used as an organic solvent. In some cases, it is also contained in small amounts in petrol. Because it is inflammable. Okay? I hope this is understood. Okay, good. Now, with this said, I think that's like the major things I want to say about ether. Let's move ahead. Okay, good. So we're done with ethers. We go to the next one. Now, the next one we're going to talk about is aldehyde. Aldehyde. Now, aldehyde is the same thing as alkanal. Did you hear what I said? So you could write aldehydes or alkanals can also be referred to as saturated aldehydes. Alkanals can also be referred to as saturated aldehydes. Alkanals can also be referred to as saturated aldehydes. So when I say alkanal, alkanals are aldehydes. That's what I'm just going to say. Are you there?
Yeah.
Now, what are you going to see? And you will know that the substance is an aldehyde. It's very simple. So, you will see what we refer to. So, once you're talking about an aldehyde or alkanal, how you will know an aldehyde or alkanal is by terminal carbonyl ending with hydrogen. So what is a carbonyl group? Carbonyl is when carbon forms double bond to oxygen. So if that carbon double bond to oxygen now ends with hydrogen, it is an aldehyde. Another way of writing it, if you don't see it like this, is you see it like this, CH. So take note, if the carbonyl group is occurring at the extreme and ends with hydrogen, it is for aldehydes or alkanals. Are you getting what I'm saying?
Yeah.
Okay, so that's that basically. Now, the other thing I would like to say to support this is that there is another group of compounds, listen, that also have carbonyl group as their functional group. And that group is called ketone. And I told you that alkanones, okay, I did not mention this, but alkanones are saturated ketones, so they are the same thing. So look at this. If it is ketone, it will be non-terminal carbonyl. What does that mean? It means that this C double bond O will be between carbon atoms. Did you hear what I said?
Yeah.
If the C double bond O is at the extreme and then ends with hydrogen, it is alkanal. But if it is between carbon atoms, then it is referred to as an alkanol or ketone. Is this clear?
Yeah.
Oh, yeah. Are you done writing? If you are done, you tell me.
Yes.
Okay, good. So,
I'm done.
good. So if I tell you now to differentiate between which one of them is an alkanal, which one of them is an alkanol, if you write this, another way to write, let me just put that down as an extra. If you don't see it like this, you will see it like this, RCOR. They write the CO like this. If you don't see it like this, you see it like this. I know I'm showing you this thing because sometimes they just use the condensed form. Have you put that down?
Yes.
Okay, good. So let's get to work. So if, for instance, I tell you that you have CH3, CH2, C double bond O, CH3, CH3, CH2, CH2, CHO, CH3, CO, CH3, CH3, CH2, CHO. Oh yeah, which ones are aldehydes? Which ones are ketones? Be fast though, there's no time. Which ones are aldehydes? Which ones are ketones?
A is ketone.
A is a ketone. Good. Now, this ketone has 1, 2, 3, 4. 4 carbon atoms. So we are going to call it but. Now, if it's but because it's 4 carbon. Now, do you notice that they are only single bonds?
Yes.
And when they are only single bond, but and. Are you getting what I'm saying? Before we now put own is on number 2, so butan 2 own. Did you see how I named this guy now?
Yeah.
Is this one an aldehyde or a ketone?
Aldehyde.
Good. So which means it has 4 carbon atoms, 4, which is but, only single bond, so butan, and then it's an alkanal, so but and now. You know, if it is on number 1, it's still the same thing as without number. 1x and x are the same thing. Do you get what I'm saying?
Yeah.
Then this one, aldehyde or ketone? Aldehyde or ketone?
Aldehyde.
You are not thinking straight. If you think straight, look at the last thing I gave you. Look at it. Think well. Open your mind. Imagine again. Look at the last structure I gave you. I said there are 2 ways to write ketone. If you don't see it like this, where it is between carbon, you see it as CO, between carbon. So I ask again, aldehyde or ketone?
Ketone.
Are you sure?
Yeah.
Good. Now, if you are to name it, it is 1, 2, 3, bar.
Yeah.
And there is, so 3 is prop. It's only single bond, so propan. And then it's on number 2, so propan 2O. Do you understand what I'm saying?
Yeah.
Then this one, aldehyde or ketone? Check your note, be checking your note. Aldehyde or ketone?
Aldehyde.
Good. So this is 1, 2, 3. 3 is prop. Only single bond. And then because it's an aldehyde, alkanal, so prop and al. And that's that basically. Now these two, are they going to be isomers or not? Let's go back a little bit to what we discussed earlier on. Are they isomers? Open your notes. Open to that functional isomer part and look at it.
Yeah.
Have you opened it? There are 3 groups of compounds I said. Number 1 is alkanals and alkanones with the same carbon atom. So are these 2 functional isomers?
Yes.
Yes. Then is butanol and propanone, are they functional isomers? But and prop, are they functional isomers?
No, no,
No.
no.
But what about proper noun and proper noun? Are they functional isomers?
Yes.
Yes. I hope you get the points now. I have put down these things. Put down these things. Put down these things. So we'll move ahead. We'll not do naming today for want of time. I don't know tomorrow's class. But before, I'm going to send you some things to study, and I'll chat you up again in the night to check up on some things. I'll give you, I'll send across a link or two links to study. Then the element you are going to study today is hydrogen. What element did I say you're going to study today?
Hydrogen.
You will study that hydrogen and the link I'm going to send you. Hydrogen and the two links I'm going to send you. Study it. Just read it up very, very well. Once you read it up, the link is just a 20 something minutes video. Just look through it. It's empirical formula. Learn empirical formula very well. Then study hydrogen. Now, in hydrogen, emphasis, Bosch process. What did I say I'm emphasizing now?
Wash process.
Okay, because I'm going to ask you tomorrow in tomorrow's class. We're going to round off soon. Now, I said, okay, we're done with this, right? We're done with this. Are you done writing?
No.
Okay, all right, finish up. Finish up. So tomorrow's class might be extended, like as in, can you take 4 hours?
Yes.
You can take up to 4 hours, right?
Yes.
Okay, don't worry. So tomorrow's class might, I'm not sure, might. It's under probability. Might. Well, yeah, I think we can work with that so that we'll be able to
Time.
the same time, 11. Do you want earlier? You want later? Away. That later is not going to work out for me. Bro. Boss. Victor. 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 Do you guys come out tomorrow? I know if you come your side, guy. Guy, like, I know me and lights for this area, we get issue. Thank you. I'll call you. This light issue na like, I know they constant. Before you go know say morning, you go day. But now, before it was 8 p.m. Now they bring it by 12 a.m. Like yesterday now. 12 a.m. guy. Day for science. I don't understand the light again. Sorry, I'm so sorry about that. Where was I? Let's come back. So, yeah. Having said this, the next thing we are going to talk about, we are done with alkanals and hey, before I leave alkanals and alkanols, there's something I want to say about them. Did you notice that primary alkanol will give alkanal, and that alkanal can be further oxidized to alkanoic acid? Are you listening? Hello?
Yes.
Which means if I ask you
Yes.
lab preparation of alkanal, what is your answer? Oh yeah. There are two here now. There are two. Go forward from alkanol or go backward from alkanoic acid. The forward for this one is what? Oxidation of a primary alkanol will give an alkanal. Are you seeing how lab preparations come about now?
Yes.
Good. But in this case, you are going backward. You know the forward is oxidation. The backward will now be reduction. So reduction of an alkanoic acid will also give an alkanal. Did you get what I just said?
Yeah.
Good. And you can write that down on your own. Now, the most popular reducing agent that is used is lithium tetrahydroaluminate 3, LiAlH4. This is the most popular reducing agent that is used in organic chemistry. So once you see this guy reacting with anybody, know that it's reduction. Lithium tetrahydroaluminate 3. So take note of that. Done?
No.
Okay, put that down quickly. So you write popular reducing agent. But for this one now, what are we going to use here? KMNO4 to get alkanal. So you can write it down. Two methods of preparing an alkanal. One, oxidizing primary alkanol. Number two, reducing primary alkanoic acid using this guy. Oh yeah. If you are done writing, you tell me.
I'm done.
Good. Now, what are you going to notice from this particular statement now? You know, alkanals can be further oxidized. But if it is secondary alkanol and it gives alkanone, can this alkanone be further oxidized? No. Are you listening to me? So what's the difference between alkanal and alkanone? Give me one difference between alkanal and alkanone.
Alkanal.
Uh-huh.
Terminal.
No, based on what I just said, leave the terminal and non-terminal, leave it for now. But based on what we just said now, alkanal can be further oxidized to alkanoic acid. Can alkanone be further oxidized?
No.
So what is the difference between an alkanal and an alkanone? What do you have?
An alkanal can be further oxidized.
Good.
While an alkanal cannot be further.
Good. Now, so what I want you to do is write it down like this. Alkanals can be further oxidized by see the popular things they used to oxidize them. Fellings reagent, Benedict solution. Okay, if it's Fellings reagent, brick red, that's the color you will see if you react with alkanal. If it is Benedict solution, it will give red or orange. Then the last one is Tolune's reagent. Tolune's reagent is what we refer to as ammonical silver nitrate, and it will give silver coating of test tube. Please, all these things are for positive reactions. That is when oxidation occurs. Fellings will give brick red. When oxidation occurs, Benedict will give orange or red. When oxidation occurs with Tolune's reagent, it will give silver coating. Are you done?
Yeah.
Good. So we are done with that. Then you now write alkanones cannot be oxidized by any of those guys above. Alkanones cannot be oxidized by any of those guys above. Done?
No.
Okay, be fast.
I'm done.
Okay, very good. So have you seen how to differentiate between an alkanal and alkanone?
Yeah.
Alkanals will react with Tolune's reagent, it will react with Benedict solution, it will react with Fellings reagent, but alkanones will not react with them. Are you getting my points now? Did you get this thing?
Yeah.
Okay, now, before I go to the next reaction, I just want to highlight also one more point about alkanals and alkanones. The reagent that is used to show if a substance is an alkanal or alkanone is called Brady's reagent. Brady's reagent is used to identify alkanals and alkanones, not differentiate. If it is differentiating, use Tolune's reagent. But when you want to show if it is either an alkanal or an alkanone, any one of them, is you are going to use Brady's reagent. Used to identify alkanal and alkanone by giving a yellow coloration. Okay? Done?
Yes.
Okay, very good. Now, this Brady's reagent, the chemical formula, just in case they give you the IUPAC name instead, is 2,4-dinitrophenylhydrazine. Hydrazine. 2,4-dinitrophenylhydrazine. Okay. Are you done?
Yeah.
Okay, good. Okay. So let's continue. We go to the next one. And the next functional group we're going to be highlighting is carboxylic acid. Carboxylic acid. Now, the carboxylic acid is characterized by COOH. What did I say?
It is characterized by COOH.
So that's that. COOH. If you don't see it like this, that's alkanoic acid. You either a carboxylic alkanoic acids. Alkanoic acids are saturated carboxylic acids. So this is called the carboxyl group or carboxylic group. If you don't see it like this, you see it like this. COOH, COOH. Or you see it like this, CO2H. All these things now, what did I call them? Carboxyl or carboxylic group. Clear?
Fine.
Have you written this?
Yeah.
Okay, very good. Now, I want to talk about the next one, which is ester. Now, you know that carboxylic is COOH, right?
Yeah.
Now, if it was an ester, just know that this H will not be there. It will just be COO, then any other thing. That's ester. So this is called carboxylate group. So if I write CH3 COOH and I write CH3 COO C2H5, which one is a carboxylic acid? Which one is an ester? A or B? Which one is carboxylic acid? Which one is ester?
A is carboxylic.
Exactly. Then B is what? Ester. Are you getting what I'm saying? Okay, so important things to note now is how do I form esters? That's the question. Are you done writing this so that we'll talk about that?
Yes.
So you write esters are formed by esterification reaction. Esters are formed by esterification reaction. Esters are formed by esterification reaction. So when you say esterification reaction, what exactly do you mean? Esterification is a reaction between an alkanoic acid or a carboxylic acid and an alkanol or alcohol to give ester and water as the only products of the reaction. The catalyst used is H2SO4. Catalyst. I put this down. Put this down. Good. So this is a very important reaction. Why? If you have RCOO H plus OH. I want you to notice something. What basically happens in esterification? This is not exactly what happens, but this is how to form the reaction. This is the easiest way to understand the reaction. Because what happens is OH leaves from here and H leaves from here. So they now join. But let's use this instead. It will make it easier to understand. Take this R here and put it where hydrogen used to be. And collect this hydrogen and attach it to OH. So which means your product will now be RCOO. Instead of having hydrogen here, what are you going to replace it with? The R that was here. Are you still with me?
Yes.
Then you form water, H2O. That's that. Let's try it with a compound. Watch this. CH3COOH plus CH3OH. What is going to be the product? This part, maintain it. So just rewrite it. It will be CH3COO. Then instead of putting hydrogen, what are you going to put? You take this and put here. CH3 plus H2. That's that. Did you understand this?
Yes.
Should I do another one or did you understand this one? Okay, let me give you one to do. Let me give you one to do. Okay, do this one. If you have HCOOH plus C3H7OH, what is going to be the product? Yeah, tell me. Call it. Yes. I'm waiting. No. H COO C CH. You're writing everything now, like just this. C3H7 plus H2O. Yes. Yeah. And that's that. Okay, try this one. Try this one. Try this one. If you had, for instance, that you had C5H11COOH plus C2H5OH. Yes. What is going to be the product? Uh-huh. Go on. H11 COO. Uh-huh. I'm listening. C2H5, then water. That's all. Correct. Good. Put this down. Before I talk about how to name them, put this down quickly. I'll talk about how to name them. We'll do amines and amides and call it off for today. Okay, very good. Now, how do you name esters? It's important you also know how to name esters because they can come from the angle of naming. Okay, sorry, let me bring this back. I'm just going to clean one part so that we'll name these ones that are already here. Now, when you are naming an ester, it's very simple. You see this part of an ester, this part from the carboxylic acid is called the alkanoid. It's called what? The alkanoid. Are you with me? And it is the parent. While this part from the alkanol is called alkyl. Now please, I have a question for you. If, let's say, a parent and a child are walking on an express road, will the child be behind the parent or in front of the parent? In front, which means alkyl will be first. Then you now call this one second. Did you understand what I just did?
Yes.
Good. So with that said, let's get to work. If I say I want to name this compound, like this one now, this is the alkyl. This is the alkanoid. Remember, alkyl, alkanoid. Now this alkyl part has one carbon. One is met, so it's methyl. Are you following?
Yes.
Then this alkanoid part has two carbons, so it's ethanoid. Are you following?
Yes.
You call this one first, you call this one second. What will be the name? Methyl ethanoid. you understand?
Oh, like how would you explain it?
Earth, two carbon. There's one carbon here. There's one carbon here. So it's two carbon. Earth. Do you understand? So that's that. Name this one. Name this one. How many carbon is here? Three. Three is prop. So propyl, right? Then here, how many carbon is here?
Okay. One.
So it's methanoate. So if you name the compound now, what would be the name of this compound? It will be what? Propyl
Propyl methanol.
methanoate. Hope it's clear.
Yes.
Okay, good. Oh yeah, I'll name them. So I will talk about amines and amines and we'll call it off for today's class. Tomorrow, same time, right? 11. You said you want it to be later. Later is like how later?
Like 12.
Hey, hey. It will fear since we are going to do like an extended class. So let's just leave it by that time, okay? Okay? Did you hear?
Yes.
Okay, let's continue. Now, yeah, so let's take this out. Now, what are amines? Amines are formed from ammonia. You know ammonia now? What's the formula of ammonia? What's the formula of ammonia?
H2.
N?
H3.
Good. So one hydrogen here, one hydrogen here, one hydrogen here. So, if you want to form an amine, all you need to do is to replace hydrogen with a carbon chain. So which means amine, the first type of amine that will be formed is primary. If you replace one of these hydrogen and put one carbon chain, you have formed a primary amine. Are you seeing how to do this one? It's different from alcohol's own. Are you following what I'm doing now? Mona,
Yes.
did you follow what I just said?
Yes.
Good. Okay. You used to answer sometimes. I used to wonder as if you are feeling sleepy. Eh? Are you feeling sleepy?
No.
Okay. No, okay, this is how I used to talk. Very gentle. What school are you going to now? What secondary school are you in?
Yes.
HRC. Oh, wow, that's cool school. Let's continue, Sha. Let's continue. Now, with this said, if you replace this ammonia, but when you replace one hydrogen with carbon chain, it becomes primary amine. Please, what I want you to note is this. Primary amine has two hydrogen atoms and one alkyl group directly attached to nitrogen. Write it like that. Two emphasis, two hydrogen and one alkyl group. Alkyl or aryl group. But the emphasis now is two hydrogen. That's what I want you to know. So look at this thing now. If you want to know if a substance is a primary amine, all you need to do is look at the formula. If you look at the formula and notice that the nitrogen in the compound has two hydrogen. Once the nitrogen in the compound has two hydrogen, it is primary. Oh yeah, look at this thing. Is it primary?
Yes.
It's primary. Once nitrogen attached to carbon has two hydrogen atoms, it is primary. Leave the alkyl. You know it's one alkyl and two hydrogen, but if you use alkyl now, it will confuse you. If you look at this thing now, you don't know how many alkyls are attached, but you can use the hydrogen to always know. It's the easiest way to know it. Now, if I now have secondary means that I'm going to replace two hydrogens with two alkyl groups, which means how many hydrogen will be in secondary now?
One.
Thank you. Good. Secondary amine means that there will be one hydrogen and two alkyls attached to nitrogen. Alkyl or aryl, anyone. That means tertiary. How many hydrogen will be in tertiary? It will replace the three of them. So how many hydrogen will be in tertiary?
No hydrogen.
No hydrogen attached to nitrogen. I hope this is clear.
Yes.
Good. Now, amides are similar. The difference between amide and amide, I see an amide. Now look, if it is amine, carbon single bond to nitrogen. If nitrogen has two hydrogen, it's primary. If that's one, it's secondary. If that's none, it's tertiary. Amide is not carbon to nitrogen. Amide is carbonyl to nitrogen. So once you see C double bond O and then nitrogen, or you see CO nitrogen, this is no longer amine. What is this one now? Amide. This one is amine. This one is what? Amide. Are you with me? I
Yeah.
hope you got this thing I just said.
Amide.
Good. Now it's the same thing. If you have CO attached to N and you have two hydrogen, this one is primary amide. If you have C double bond O and you have one hydrogen, this one is secondary amide. Then if you have CO attached to nitrogen and there is no hydrogen, it becomes tertiary amide. Did you get this now?
Yeah.
Very good. So we'll be stopping here for today. Your read up for today, the element you are reading for today is hydrogen. What did I say you are reading? Hydrogen. And I'm going to send a link to you right now. I think you should just do the study right now. Since you are with mommy's phone, just do it. It's a 20 minutes class on how to do, I'll send you two studies, empirical formula and stoichiometry. Just do the study. If you can do it, just do it now. Do you understand what I'm saying? So that it will help us save time and we'll just talk about important topics in the 6 days we have. We don't have time. Okay? Okay? I'm sure you're going to do well.
Okay.
So just trust me. So read up hydrogen, finish it. Okay, I think you will do the study now. Maybe you might not finish everything. You don't want to do it now.
The battery is already.
The battery is low. Okay. Good. But I'll send it now. I'll call mommy. I'll call in the next 2 hours to check if you've done it. Did you hear what I said? So I'm going to send 2 studies. Finish those 2 studies. Anything you don't understand, tomorrow we'll start with that. Trash those ones, then continue. We'll do naming tomorrow. We'll finish up naming. We've started naming. We'll finish it tomorrow, and then get into redox and electrolysis. Then next tomorrow we'll do thermo and periodic table together. We'll do it like this till we finish everything. Thank you very much for joining my class. See you. You can leave the call now.
Thank
Yeah, I'll send the link right now. Yeah.